Hi, ladies and gentlemen. We're talking about Chapter 9 for at least the start of today. We're starting with Chapter 9. Real simple stuff here. Hopefully, we're going to be graphing quadratic functions. You guys can write down your essential question, the big characteristics of quadratic functions. We have some vocabulary words that would be very helpful for you to write down. There's a parent function, which is the parent of all of our functions. It's where all functions are coming from in the form of x squared, for quadratics at least. And then there's the standard form of quadratic functions where we have the ax squared plus bx plus c. There's this axis of symmetry. It's just the line of symmetry for a parabola. The formula is x is equal to the opposite of b over 2a. And then we have our y-intercepts, which is the c. The c is over here, you can see, for our graphing. And then there's the maximums and the minimums of where a parabola peaks or bottoms out. So I'll give you a couple examples here. So if this were to be my parabola, it's a U-shaped graph, the vertex is up here, and this would also be the maximum because it's the highest value that y could possibly be. It has an axis of symmetry along this line because this is the folding point where the parabola could fold onto itself. Now parabolas could also be facing upward, where this vertex is going to be the lowest point, so that would be a minimum value. And then that minimum value just also happens to be on that same axis of symmetry line. So it's going to be important for us to be able to find that axis of symmetry so that we can find our maximum or our minimum based off of what type of a graph we have. So let's get started with our first example. Our job is to graph y equals x squared minus x minus 2 using a table of values, and then we're supposed to identify the domain and the range. Now the first thing that I want to do is I want to graph that axis of symmetry because that tells me where my line is going to be, or where half of the graph should be located to the left and half of the graph should be located to the right. So I'm going to use that formula, the opposite of b over 2a. Now this is my a, this is my b, and this is my c. So if we look at these things, a is a 1 and b is a negative 1. So the opposite of a negative 1 would be just a positive 1. So that comes from the number in front of the x. And since a is also a 1, we have 2 times a 1, which gets us to a x equals a 1/2 for my axis of symmetry. Now I'm going to draw that in this purple color. This axis of symmetry goes right along here. I'll make a dashed line where x is a 1/2. And this is going to help me figure out exactly where my vertex is. Because if x is equal to a 1/2, I can now plug that number into the formula up here to figure out what c, or my vertex, is. So if I plug that stuff in, we're going to have, sorry for the pause there, but I had someone stop at the door. Now that we know that the axis of symmetry is x is equal to 1/2, we're going to plug that into our x to figure out the y. Because if we have an x and we have a y, we then have the vertex for our parabola. So if we plug those things in, it's going to say a 1/2 squared minus a 1/2 minus 2. So 1/2 squared, I put in parentheses just to keep things simple. I don't know if that keeps things simple for you guys. Minus a 1/2 and then minus a 2 using my trusty calculator. And I got myself that then y is equal to a negative 2 1/4. So that's my ordered pair would be a 1/2 and a negative 2 1/4. Now that's going to be down here at negative 2, 1, 2, and right here 2 1/4. That will be my vertex. So that's my vertex. Now that I know that what my vertex is, and now I have my axis of symmetry, I can plug in these numbers over here to help get the other values of my parabola. So if I plug in a negative 2 into that same equation, So a negative 2 squared, which is 4, because negative 2 times negative 2 makes a 4, minus a negative 2, which turns into a plus 2, and minus a 2 makes us have a 4, because 6 minus 2 is 4. So we go to the left 2, 1, 2, and up 1, 2, 3, 4. Plug in a negative 1. Negative 1 squared, which is 1, plus 1, which is 3, minus 2, so a negative 2 and a 1. So we go to the left 1, up 1. Plug in a 0, which is then going to be a negative 2 because all those things are 0. 0 minus 2 is negative 2. So 0, negative 2. 1 is also a negative 2. So we go to the right 1, down negative 2, and go to the right 2. So plug in a 2 squared, which is 4, 4 minus 2, which is 2, 2 minus 2, which is 0. So to the right 2, got a 0 point here, right? Hopefully we just did that correctly. Now if we graph these going upward, this continues on that way, this continues on that way, and we have ourselves a beautiful parabola. Now it kind of looks like a V, but it's a U shape. Our next step is to identify the range. Remember, range is the Y values, and then the domain, which is the X values. Now the X values for all of these parabolas that go either facing upward or facing downward, the domain is going to be all real numbers because it's always going on forever and ever, ever, as wide as it goes. So that's going to be all real numbers. Okay? The range is going to be something different. Our range is the Y values. Now the Y values are going from this vertex and up. So that vertex was at the Y value of a negative. Y has to be greater than or equal to that Y value of a negative 2 1/4. So that's what my range will be for this because it's all the values of including this point and above for the Y values. All right, let's try another one. Our job is to look at the graph, find the vertex, the equation of the axis of symmetry, and then the y-intercept. So if we look at it, the vertex is right here. So my vertex, let's call that part A, is at a right 2, down 0. So ordered pair of 2, down 1, sorry, negative 1. The equation for the axis of symmetry, let's call that question 2 here. It's this vertical line right here. It's where x is equal to 2, because x is 2 at that line. And then the y-intercept, where does it cross? Well, that's where the x is 0. So let's call that step 3 here. You can see the point where it crosses is at where y is equal to 2. So x is 0, y is equal to 2 is my y-intercept. Let's see if we can try another one. Now this one is opening downward, so we can see that we're going to have a maximum value right here. So that is my vertex. I went to the right 1, 2, 3, and up, see to the right 3, and then when we went up 1, 2, 3, 4, 5, 6, 7, 8, up 8. Equation of the axis of symmetry. We have our line right here. That's to the right 1, 2, 3. So that's x is equal to 3. That's our second step. And then our y-intercept, where does it cross the y? Well, it looks like it crosses the y perfectly right there, which is at negative 1, 2, 3, 4. So we have an ordered pair of 0, negative 4. All right, folks, let's try another example. Now this stuff is a little bit more complicated than the first things. We're supposed to find the vertex, equation of the axis of symmetry, and the y-intercept from this equation. Now to find the vertex, we first have to have the axis of symmetry. So we're going to plug in that opposite of b over 2a. So into this equation over here, we're going to have a opposite of b. b is a negative 8, so the opposite of negative 8 is a positive 8, over 2a. a was negative 2, so 2 times negative 2. So this becomes an 8 over a negative 4, which is simplified to make a negative 2. So my axis equation is x is equal to negative 2. Now when I plug that in, my vertex is going to have an x value of negative 2, but we're going to use that value into our equation to find the other part of the vertex, the y value. So we plug in the negative 2. So it's going to say a negative 2 times a negative 2 squared minus an 8 times a negative 2 minus 2. So when we do all that math, I'm going to use my trusty calculator. Negative 2 times a negative 2 squared minus an 8 times a negative 2 minus 2. We get the value of 6. And since that's my y value, my vertex is at negative 2, 6. Now the y-intercept is when x is equal to 0. So if we put zeros in for x here, that means that's going to cancel out, that's going to cancel out. My y-intercept is going to be at 0, negative 2. So this number just comes in for my y-intercept. Now folks, we're going to ask you to try to solve this next question on your own. The exact same things here, but you're going to do letter B on your own. Good luck to you, and we'll help you out tomorrow more if you need it. Thank you. Burma Nation signing off.